With the explosive surge of interest in 3D technology, the University of Illinois Chicago is working to advance the limits of 3D at the Electronic Visualization Laboratory.
The Electronic Visualization Laboratory was founded in 1973 as a collaboration between art and computer science. And since then, the lab is focused on computer graphics in the 70s, video game technology in the early 80s, scientific visualization in the late 80s, virtual reality in the early 90s, high-speed networking in the late 90s, and now large high-resolution displays, all to help mostly scientists to look at their data. Well, the mission is partly to educate. You know, we're a lab in the Department of Computer Science, so mostly undergraduate seniors in computer science, master's students, PhD students, you know, learn how to visualize information, help people collaborate, and then go off in careers in science or industry. And at the same time, we work on projects for mostly the federal government to, you know, visualize science in different fields.
The current 3D technology at the lab is already enough to amaze any visitor.
So auto stereo is just a fancy way of saying stereo without glasses. It allows the viewer to see 3D without the weird red-blue glasses. The only thing is that you have to be head tracked, which essentially just tells the computer where your head is, and it redraws the entire scene specifically for you. So every time you move your head or every time you move inside the world, it redraws every frame. We have the Omega Desk, which is passive. The difference between active and passive stereo is the active stereo, like I said, redraws the scene every time you move or something. Passive stereo essentially is when you wear some type of shutter glasses or polarization. Shutter glasses are things that they flip on and off for each eye at a certain rate, so your brain can still fuse the 3D together.
Some of our projects involve things like creating new displays. So in the case behind me, we have a fairly large, high-resolution, thin border display, which is really nice for 2D data. One of the current projects is to make this dynamically 3D or 2D. So you could see three-dimensional data sets, say, floating in front of the screen, as well as high-resolution two-dimensional data sets, so scientists can juxtapose different kinds of data.
Thomas Forrest, Medill Reports, Chicago.